Hi and welcome to a new In the Mail. This episode will be slightly different because we will be taking a look at devices that I got from China, but I will also be taking them apart because I'm curious to see what we'll find inside them. So to get started, the first item is this spy camera dongle thing. These things are very cheap on eBay, but considering their price, I don't expect much out of this. So it does come with a user manual, Chinese and English as well. So this thing works with an SD card. It stores the files with an SD card, and you have a very tiny slot right here where you can insert the SD card. You have three tactile switches. This is the camera lens right here. So this thing, I don't know. Do you consider this thing to be a spy camera? I would probably notice this hole in here immediately. But anyway, I want to take a look inside and see what they used for this gadget. I think we're going to find a single chip solution that handles the camera and the storage on the SD card, and probably an extra microphone for recording audio, and probably an op-amp for that. If not, the single chip solution might include all the required analog circuitry for the microphone as well. We might see a small battery charger because this thing will have a lithium battery inside. But anyway, let's get started on opening this thing. And before I get this thing opened, I just took a short capture test, and I wanted to show you the quality that this thing records at. So I'm going to insert the video right now. This is an audio test. How is the audio captured by this device? As you saw, the audio is terrible and the video quality is even worse. You can't even distinguish the object that I'm showing in the video. The pictures are also very bad. So it's probably the shittiest camera that they could fit in here. So the spy videos that you're going to capture with this thing are probably useless. You can probably only distinguish silhouettes in those videos. I think it will only be held on by clips, so it should come off fairly easily. Okay, so we have the typical small lithium battery in here. This one is probably something around 50 milliamps. And as expected, we have the single chip solution right here. Let's see if we can read the numbers of that one. Yeah, the numbers are visible, but I'm not sure we're going to find the datasheet on this thing. Oh, we even have a vibration motor, but I'm not sure that was working because when I did a test, I couldn't feel that vibration motor. Here's our camera, which is, I don't know, something like 320 by 240 in resolution. Let me just remove this PCB entirely from the enclosure. And what's this second chip right here? So I did a search on the numbers I found on these chips. This one right here is a 25Q40, and it's a 4 megabit serial flash. It's probably used to store the configuration settings for this single chip solution right here, because this is basically an ASIC, an application specific integrated circuit. This thing handles everything in here. Apparently it handles the microphone, the camera input, the battery charging, the switches input, and this vibration motor as well. So and I almost forgot, that thing also handles the USB to SD card interface. So pretty much as I expected, to get the price down on these things, they must use a single chip solution, and of course the crappiest camera they can get. So I don't recommend you get one of these. I mean, the even the audio quality recording is very bad. There is a slight hiss you can hear in the audio, and this thing is powered by battery. So where is all that noise coming from? So this thing will go into my junk bin. I'll probably salvage the battery because it might be useful in some small battery powered project. Our next item is this radar sensor switch. So apparently we can have an input between 100 and 250 volts or something like that. The text is really blurry on this silk screen, and it can handle an output of maximum 35 watts. So this is the kind of newer microwave sensors that you get instead of PIR motion detectors. So you would mount this one probably on the ceiling, and it will detect motion and control up to 35 watts on its output. So I'm curious to see what we're going to find inside this thing. It's got all kinds of regulatory listings on here, but I'm not sure these are real or not. Anyway, I'm curious to see what they have inside, so let's open this thing. Okay, so it's a two-board construction. So I took a closer look at this thing, and it appears they're using a capacitive dropper on the input, and that's probably dropping the AC down to something like 12 volts maybe. And then that 12 volts is passed through this PCB, which has its own local regulator right here. I believe this is a 5 volts regulator, and that is what powers the main controller IC, which is a BISS 0001 PIR controller. And it's strange to find a PIR controller inside the microwave sensor controller, but apparently I did some searching, and there is a patent on Google. It's a Chinese patent on how you can use the PIR controller in a combination with microwave input to basically get motion detection from the microwave input instead of a PIR sensor. So that's what they're doing right here. They've also used an LDR to make this thing work only in low light conditions. So it will only turn on the light when there are low light conditions. And back from this control chip comes a control signal, which is this one right here marked C. I believe C comes from control. And then they have a MOSFET right here, and this larger package controlled by this smaller transistor right here. And this MOSFET is what drives this this output. And I haven't measured yet, but the MOSFET might just be placed on the line or on the neutral, and it's turning that on or off. So all the current will pass through this PCB if that's the case. And yes, because I'm seeing right here line and neutral in, and then line and neutral out. So all the current will be passing through this PCB, through that MOSFET, and that's why they're only rating this thing for 30 watts. And I'm not even sure it can do that well. It depends on the RDS on of this MOSFET they use right here. Because if the RDS on will be high enough, this MOSFET will be dropping some voltage, which in turn will cause power dissipation in the package. So that's about all we get inside this cheap microwave sensor. But I think we're going to start seeing these things in lots of lights or light controllers coming from China these days, because it's much cheaper to place a couple of passives and have this antenna on a PCB instead of using a PIR sensor. And these are also capable of greater sensitivity. Like I don't know if you're interested in that or no, but I have seen videos on YouTube where these sensors could detect movement through walls. Our next item is this 4-channel digital, note this, remote switch. So they kind of got the spelling wrong right here on the silk screen, but basically what this does, well, it should allow you to control 4 mains AC lines from this remote control. So you could use this to for example, turn on or off 4 different lights in your house, or maybe a garage door, or anything really that will fit this power rating of 1000 watts. So it says right here 1000 watts times 4. So I'm assuming each of these channels could handle up to 1000 watts. We'll see about that. I'm curious if they're using relays or transistors inside this thing to switch the outputs. Okay, so let's take a closer look inside and see what they used inside the receiver unit. The soldering job looks fairly reasonable. I was expecting much worse. Oh, okay, so we do have relays in here. And these are 12 volts DC relays with 10 amps on the switching side, rated for up to 240 volts AC. So yeah, that's not bad. At least the relays have a rating that could handle the power advertised. So I take back what I said on the soldering quality. Just look at how this IC is soldered. It's looking like he's ready to take off. So I took a look at the board and figured out what's happening in here. AC mains comes in, it goes through this bridge rectifier. Then we have this IC which is marked DK112, and this one is a switch mode power supply controller, Chinese made, and it's probably stepping down the voltage to something like 12 volts that powers the entire circuit. We then have the RF module right here, which is interfacing to the main PCB through these 4 pins right here, and I believe it gives a serial output that it's then decoded by this chip right here. So this chip is probably like a serial to parallel decoder that then feeds the signal into these 4 transistors that control the coils of these relays. So these relays are practically switching, I don't know, either live or neutral through these 4 wires to the exterior. So quite a simple construction, and I don't think you need anything more complicated than this for switching the lights in your home with a remote control. So next up, let's also take a look at the remote control. Let's see. So quite simple construction for the remote. We have the tactile switches and the single chip solution that handles reading the buttons and sending their value through the air. So let's see, the chip they're using for the transmit side is this JY5018, and on the receive side, I don't know, they look like they're using something very simple, because I see an op-amp in here, I see an LM358, so they must be using something very simple in here on the receive side. So that's how one of these looks inside, and that's what they're using to make it work. If you're interested in getting something like this, there will be links in the description below. Next, I got 4 different types of LED lights from eBay. These are the one hang low ones, very cheap. I just wanted to take a look at each one and see how different they are with respect to each other, what kind of power supplies they're using inside, and what is the overall build quality. So let's start with this one. I have shown this one before because I'm using them here in my lab and in my home. I think these are good lights, except for the fact that they have a big problem with cooling. I think these run at high enough temperature that degrades the LED over time. So they could have used slightly larger heatsink for this, and they would have been great for longer periods of time. But I have noticed that over time the LEDs start to dim, and that's a sign they are running at a high temperature that shortens their lifespan. So let's take a look inside this light and see what kind of power supply they're using. So very thin wires, and these are not silicon type. I'm not sure how well these survive the temperature that this heatsink will reach. Yeah, so they have used some Kapton tape around this power supply, but let's open that to take a closer look inside. So I got the Kapton tape off, and it looks like this thing is using the BP3116 control IC, and if I remember correctly, I think we've seen this one before, and it's a buck regulator. So that's what's powering this string of LEDs. They are soldered to this aluminum substrate type PCB, and that is attached to this aluminum heatsink with a bit of thermal paste, but not too much because you don't want to increase your expenses. As you can see, just a smudge of thermal paste they've used in here. So definitely could have used more thermal paste, and I think I'm going to add more before installing this LED light somewhere. So moving on onto the next LED light, let's take a look at this small one. I'm going to try to remove this plastic cap, hopefully without breaking it. Not sure if that's possible. Oh, one interesting feature, it seems like they have these slots for ventilation, just to let the heat escape. So that's a nice touch. I'm not sure I can open this one. I'm going to pause the video and try to separate these two. So I managed to pull it apart just by slipping the knife blade in right where they were connected, because they were glued with just a touch of glue, and that's why they weren't separating by hand. So it looks like a very simple circuit in here. Yeah, we have a capacitor dropper, a bridge rectifier, and a smoothing cap on the output, and I'm pretty sure a lot of these LEDs will be connected in series. I'm not sure how many, but I'm not going to destroy this even further to investigate that, because really it's not worth it. I was just curious about the power supply they were using. I should have expected a capacitive dropper inside such a small package. Unfortunately, I don't want to destroy this even further, because this is the one out of the bunch that I really want to keep intact and use it. Next up, let's take a look at this one. It's the smallest out of the two white ones. I believe this cap should come off. Yeah. Let's see what kind of circuit they used in here. So they're using a square PCB, but they've cut corners in here. Yeah, literally speaking. So we got the same arrangement in here. Capacitive dropper, bridge rectifier, and then smoothing cap. But this PCB looks really thin. I think this is 0.8 millimeters, and I'm not sure how hot this thing will get. I would have preferred to see one of those aluminum substrate PCBs used in this kind of LED light bulb. I'm pretty sure this will get very hot. Even though it has a limited number of LEDs, these will still produce some heat, and will get this thing very hot, I suspect. So this thing has been running for the past 10 minutes. Let's check the temperature. So it seems like the highest temperature we get here is something like 68 degrees, 69. Yeah, 70 degrees Celsius. That's quite a high temperature, and I believe it's going to get even higher if I let this thing run for hours. And that will for sure shorten the life of these LEDs. This is just a plastic case right here, so this thing will not help dissipate the heat to the environment at all. Like there's even minimal contact between the PCB and this outer plastic shell. So this right here, I think it's bad design. At least if they would have used one of those aluminum backing PCBs, I think this might have been running a couple of degrees lower. And the best of all is when they use some kind of metallic enclosure, because that will help dissipate the heat out in the environment. Next, let's take a look at this bigger one. It should also come off the same way. Okay, this plastic dome comes off. So now I see they have these plastic clips in here. Yeah, I'm going to pause the video and try to remove this off camera. So I managed to unlock the PCB, and we have exactly the same power supply circuit, capacitive dropper, bridge rectifier and smoothing cap. And the same thin PCB is used with no aluminum backing. So the cooling on this thing is going to be as worse as we saw on this smaller one. So let's do a temperature test after letting the light bulb run for 10 minutes. The light has been running for the past 10 minutes or so. So let's check the temperature. So once again over 70 degrees Celsius and climbing. But at least this light bulb does have some holes provisioned for air cooling, and there might be some air circulating when this light bulb is mounted in this position. So due to natural convection process, the air might be circulating and cooling this PCB a bit more than this one that we showed earlier. So that was all for today. It was kind of different, me taking these things apart and talking about what I find inside without any script, without any prior knowledge. I might have gotten some things wrong, or you might hear me bumble, but I wanted to give it a try. If you enjoyed the video, please hit the like button, and I will see you next time.